Today, I am playing Donkey Kong Junior Math. I am not going to pretend to be happy or excited about this. It is simply a bad game. And honestly, it's difficult to even call this a game. If you get stuck and you want to, you can just run this question mark up and it will solve the problem for you. However, you get no points for that. That's the only time I am going to do this. The rest of it, I will be playing this straight, more or less. Um, yeah, you climb up the little chains to control the numbers you get, and that's the entire game. So I figured that instead of talking about this uh, silly game of which there is nothing really to say, I'm going to talk about my experience with math. I think there's at least a little bit more there. Um, Math has always been my favorite subject as a kid. I remember in my basement, my dad had a blackboard in his workout room in the basement. And while he was like on the Nordic track or lifting weights or something, I'd be on his blackboard giving myself math problems to solve and solving them. That's how I had fun. I think he intended to use it to sort of. I think I need to carry the one there to like track, weights or workouts or whatever. But he did let me set up my math problems there. I got a lot of good practice out of that. Um, I had this little pretend game where like the math marines that I would make my friends at school play with me. Where like you're like a pretend military and like you rank up by solving math problems. And like if you don't get a problem right, then you need to go see the medic who is responsible for giving you remediation. So clearly, I was not the most popular kid in school, but that's what I did for fun. Um, I do understand the problem with that approach nowadays, but as a kid, that's what I was into. Um, in middle school, we did this math counts competition, and I thought it was really cool. It was a opportunity to dig a little bit more into it. But like the math teacher's son was the only one who actually knew what was going on. I don't feel like we were being really trained to handle the sorts of problems we would see there. Like they would just throw sample problems at us that were like way over my head, and then go over the solution, and I just did not get anything out of that. We did go to state though, and by we, I mean it was the math teacher's son who carried us all there. He did all the work, but we did go to state, and he got some sort of a fancy calculator prize there. So that was a cool experience, I guess. No, that's not what I want to do. No. Okay, that's another problem with this game. It's annoying to select the correct exercise. There we go. 3-digit subtraction. So then, I went to a private school for elementary school and middle school. Let's see. 11 minus 9 is 2. Then that's a 5 now, so that's going to be 3. I went to a private middle school and elementary school. So I did not get to take algebra in 8th grade. I only got up to pre-algebra. And I felt really upset with that because the other people going into the public high school, like the smart kids, had already taken algebra and going straight into geometry, and I was going to have to take, algebra instead of geometry, and I was quite unhappy with that. But I did eventually convince my parents that I could get away with skipping algebra. What did I mess up there? Oh, right. I thought I carried a 1 too many. It took a lot of convincing to let my parents sign off on me skipping algebra, and they got me a textbook to use over the summer, and that's how I studied it, and it was fine. You know, it's my cat is playing with my headphones, so this is very difficult. By the time we got to Algebra 2, you know, everyone had basically forgotten all the Algebra 1 stuff because there'd been like an entire year of not using it, you know? So, let's see, 11 minus 6 is 5, and that's an 8 minus 2 is 6. So we're going to have to go back and review it anyway, and, you know, since I pick on stuff pretty quickly, it worked out pretty fine, and I got to go into geometry, which was... Oh my god, they make it so dull. Like, it could be so cool. And proofs are so cool, but they just make it, like, so cookie-cutter, and they suck the entire soul out of it. I was really unhappy. Let's see, around that time I started going to the library and finding math books there to read. I remember one of them was a tour of the calculus by Bierlinski, something like that. I would hate it if I reread it nowadays. You know, it's so full of just purple prose. It's utterly ostentatious. It goes out of its way to make stuff more significant than it really is. And my current cynical self would just be utterly disgusted with it. But as a high schooler, that was the exact sort of cringe exultation that I needed right then. And it really hooked me in. It really showed me how cool math was. Also, I think the author is like a young Earth creationist or something, so that's... Oh, I thought I didn't realize the answer was actually 9. I was going to swing to the next chain and check, but okay, I guess that works. I also read Letters to a Young Mathematician, and I don't really have any concrete takeaways from that, but I do remember it. I really loved reading it. It did shape in some sense. Oh, come on! It did shape in some sense how I thought of math. And I guess I kind of like to read that again and get a better feeling of it too. I read Fermat's Enigma, which is all about the search for Fermat's last theorem. Gödel, Escher, Bach, of course, is a classic. Let's see, we carry the 1, so that's going to be up to a 7. Then we carry the 1 again, 6. And at some point, I was reading about like the different kinds of infinities and such, which was utterly mind-blowing. I think one of the things where sorry, I'm having to think a little bit harder here. One of the things where I got really sucked in, I read An Introduction to Graph Theory towards the end of high school, which was like, I guess, a kind introduction to the sort of like proof-based math, but like accessible at a high school level, right? So I learned a little bit about graph theory, and as I was reading that, someone on Facebook, one of the moms on Facebook shared, what did I get wrong there? Oh, because I had to carry the 1. My bad. So that's an 8. She shared a problem that I did not know at the time, but it was basically equivalent to the Bridges of Kecksberg problem. And in my graph theory book, I had not gotten far enough to have read about the problem and the solution to it yet. But I did get far enough that I could reinterpret that problem through the abstraction of graphs and come to my own proof that it was unsolvable. And that made me feel incredibly powerful. And that, like, it really sucked me in. I think that's right. Let's see, did I read anything else in high school? My dad got me I Am a Strange Loop from the library. It was kind of the sequel to Little Lesher Bach, but I think it was too far over my head. Did not get into that. That's going to be a 7. No, I can't think of any other high school books. Oh, I got really grumpy with how the pre-calculus teacher was teaching pre-calculus. So she was, a bit loose on her definition of asymptotes. She just straight up said, like, I don't care about combinatorics. I think it's stupid, so we're gonna go light on this. And nowadays I'm definitely on her side there. Combinatorics is bullshit. At the time, I was a very intense child, and just hearing a teacher say she didn't care about the subject she was teaching, that got me really grumpy. So I started up like a clandestine newsletter, where again, I am not like super proud of this. It's I'm definitely more mature as an adult than as a child. I forgot to carry the 1 again. But I started a little clandestine newsletter to send out like corrections to what she said in class. My calculus teacher, let's see, you gotta carry the 1 there. My calculus teacher incorrectly claimed that there are more integers than natural numbers, which I guess I haven't gotten too far into that infinity stuff. There are arguably different ways to count it, as far as I understand. What people typically think of in terms of like a cardinality, that is simply not the case, and I had read enough to understand that at the time, but he was otherwise, I don't know. I thought he was a good teacher at the time, but, looking back, he did let his frustration get the better of him too many times. I think it was not very welcoming to the sort of worst performing students in the class. And looking back, I don't think he was as great a teacher. If you're explaining things in an engaging way to the people who are already good at it, that doesn't really count if the people who are bad at it are feeling left out and belittled, right? Like the people who are good at it are going to get it regardless of, how poorly you explain things. It's how do you treat the struggling people in your class? That's kind of what makes you one of the things that separates a good teacher from a bad teacher. No, I meant 0. I meant 0. Oh my god. Sorry, the controls in this game are so awful. Okay, so this is a 1. This is a 0. There we go. In college, I started out as a double major with math and piano. I took a linear algebra course, and it was so stupid. There is no reason to manually do operations on 4x4 matrices by hand. That's what computers are for. I have better things to do with my time, and I am very grumpy about that. I'm friends with a guy who has a master's degree in statistics, and he insists that, doing all those manual computations is actually key to understanding the subject. He actually has an advanced degree, so it's natural to assume he knows what he's talking about. Nonetheless, I vehemently disagree. Manual matrix operations are stupid, and I have a computer. Oh, that should be a 3 at the end. And that was actually the only math class I took in college, even though I was trying to do a double major. I forget exactly what happened. Maybe I switched to music only early in the process or something, but I really wanted to take like abstract algebra or like some sort of a proof-based course, but I never got the chance before I dropped out. Well, let's see. I think I need to reduce that by 1 there. Okay, there we go. So then after that, like I started... After I dropped out of college the first time, I started doing this for fun. Like I found a linear algebra done right by Axler. I tried to work through that. Let's see, that's an 8. So that's going to be a 2. And that's going to be a 2. And oh my god, that was hell. It made my head spin. I don't know why I chose more linear algebra. I tried Spivak's calculus. I tried his calculus on manifolds. They were both way too hard for me and over my head. What an easy problem there. And I kept punching above my weight and getting really discouraged, and I ended up taking a pretty long break. Let's see, that's going to be a 1. That's going to be a 9. And now I finally have time to get back into it. I've gotten Terence Tao's book on real analysis. I am loving it so far. He has very friendly explanations. So, let's see, that was 4-digit subtraction. I need to remember that to choose the next one. Maybe I'll choose the correct stage this time. He has really friendly explanations. For example, I remember in my high school calculus textbook, just staring at the... Why do I need to start with this digit? Come on. Staring at... No! That's supposed to be a 6! I remember staring at the epsilon delta definition of a limit. And just sitting there for hours, trying to work out what was going on. And, you know, I eventually got it, but it was painful. I don't think I ever actually worked through any of the epsilon delta proofs in high school. And yeah, it was just a very miserable experience. But in the analysis textbook, you know, so he starts by constructing the natural numbers from the Peano axioms, and then going on to construct the integers and the rational numbers. And then once he has the rational numbers, he's like, okay, so there's this concept we're going to talk about, where 2 rational numbers are epsilon close. And this isn't something that's used in real math, but I'm introducing it in this book as a building block, right? So 2 rational numbers are epsilon close when their distance, the distance between them is less than or equal to epsilon. So pretty simple. And then later on, he builds on that a little bit. You know, he talks about sequences of real numbers that are, this is going to be 30, epsilon steady, where after any 2 numbers in the sequence are within epsilon of each other, right? So that's, you know, taking that same idea and building a little bit on top of it. And he adds a little more and a little more and a little more until when he finally introduces the full epsilon delta definition of a limit, like, it's just adding one more piece on top of the machinery you already have, right? So it was very friendly. You've already built up the understanding of so many of the required components, and I just love how he did that. I am a very big fan. I'm about halfway through the book now, and so far it's all been devoted to constructing the real numbers. So stuff I'm, you know, mostly familiar with. I'm kind of scared of what comes next. It's going to break into, you know, sequences and like what people typically actually study in analysis. Okay, thank God that was the right one. Oh God, I'm going to have to focus here. And then like the book 2 is stuff I've never even heard of, so we'll see what happens, I guess. And then I also have a huge book, Damit and Foot, on abstract algebra, which... excuse me, I've tried to study that several times. And I lose interest because they're always so bad at the motivation. They're just like, okay, this is what a group is. We're going to study it. Trust me, this is actually interesting. And then it just never sticks with me long enough to see why it's actually interesting. So I'm disappointed in myself for not sticking with it. I'm disappointed in the textbook authors for not motivating it. But I also picked up Algebraic Number Theory for Beginners. And I haven't worked all the way through it yet. Let's see, there we go. Yeah, so I picked up Algebraic Number Theory for Beginners. And the way this book opens is they talk about, the standard results about, there's an infinite number of primes, what it means to, factorize things, things of that nature. And then they're like, okay, let's generalize prime factorization to polynomials and things that aren't just natural numbers. Oh, and look, when you try to do this, we get the field axioms. Like, oh, this is actually cool. I see the point now. Thank you. So I'm really excited to dig more into that once I finish analysis. I think that's an 8. I feel the book is a little bit unfriendly. It's just sort of gives sketches of what they're trying to prove and talk about, and you have to fill in the rest. Tao's analysis books are a lot more thorough, but I guess as my mathematical skill increases, and I gain some maturity there, that's the kind of stuff I'm going to have to deal with, so I guess I'd better get used to it, just being mature enough to fill in the gaps on my own. There's a scary thought, no one holding my hand anymore. But I guess that's what I signed up for, so let's do it. That's my entire math journey, and we still have, 3 levels left, so I don't know what I'm going to talk about now. Well, come on, what's wrong with you? Oh, I went up to 3. Go away. Oh god, why does he start on the opposite end from where he needs to be? That is nonsense. Right, so he starts on the far left. And the first thing we have to do is walk all the way to the other side of the screen. And he moves so slowly. Okay, that's 8. I mean, I guess physics is cool too. We can talk about that. But I haven't touched physics since high school, so I don't have anything to say. I was looking into the earliest physics experiment conducted, and it was something about proving that air was a substance by using something with water. I'm just rambling now. I have no idea what I'm talking about. And okay, this is another... (11 minus 5 is 6. 6 minus 2 is 4. So, this is another thing that sort of only exists to be painful. If you can subtract 3 different numbers, subtracting, what is this, 1, 2, 3, 4, 5, 6, 7-digit numbers? It's the exact same thing. right? So, like, you're not learning anything new. It's just a more painful way of doing stuff. Oh, that should have been a 1. It's just a more painful way of doing stuff you already proved that you can do. So, like, there is no reason to have these kind of problems. Like, maybe, like, 1, just to prove that it's the same process or something like that, but, like, oh, come on, just, like, sitting here and subtracting 7 digits, that's so boring and useless. But I guess I'm going to get really good at this mental arithmetic here. There we go. And we still have 2.5 levels to go after this. Okay, 8, so that's going to be a 5, so that's good. And that's a 16, minus 7, 5. Okay, there we go, that worked out. I don't know, maybe I can talk about programming. That's math adjacent. I'm a professional software engineer. I should have something to say about that. When I was a kid, I thought I hated computers and I was not good at them because I just didn't understand what was going on. And yeah, it was all just a confusing black box to me, you know? Like, I could do stuff on a computer, like I didn't understand what it was, you know? And that's see, that's a 12 minus 9, so that's correct, I think. There we go. But yeah, I thought I hated computers, and like I carried that bias like all the way through my first attempt at university. You know, then I dropped out and I didn't have access to a piano anymore. So I needed a new hobby. 11 minus 5 is 6. 5 minus 1 is 4. 9, that's a 6, so that's going to be a 4. Yeah, so I needed a new hobby, so I taught myself Python. Oh, that should be a 5. And I guess on that note, teaching yourself is like the accepted way of saying it. Everyone understands what you're talking about. But, like, I feel grumpy about that way of phrasing it. You know, like, I was at the ice skating rink today, and I taught myself how to do free turns. But, you know, I didn't actually teach myself. You know, I learned it by watching Coach Julia on YouTube, right? She's the one who taught me. And, like, I understand the meaning that, like, you know, it's like I don't have a teacher working with me one-on-one. I'm searching out my own resources and finding it through there. But, like, it seems unfair to the people putting in the work to create those resources to then go and say, oh, no, I taught myself. Like, no, I don't think I taught myself. Coach Julia taught me. She taught me online, on YouTube, right? But anyway, I digress. I taught myself Python, but I forget the sources I used. I wasn't in school or anything for it. Let's see, that's a 5. 8 minus 1 is 7. And I learned to make simple games like Snake and Tetris and that sort of thing. And I had a blast with that. And then I saw someone saying on the internet, like, hey, you know, people pay pretty well for this sort of thing, right? So I went and I got an online degree for it. I was doing that while working full time. It sucked. Okay, 2 levels left. But I got through it. I had to do it in Java, which is definitely not my favorite language. It is very verbose. I work in C++ now. Hang on. This is going to be a 0. And that's going to be carry the 2, so that's going to be 58. Okay, there's a lot to think about here. I might have to actually be thinking about the problem now and actually talk about the game. Which is fine, because there's no way that anyone is still watching. because it's DK Junior Math. This is an awful game. And the people who follow my channel are unlikely to be the sort of people who are interested in math ramblings. So it's okay. I can talk about the game, and I am not inconveniencing anyone because nobody is watching. So let's do it. 2 times 1 is 2. 2 times 3 is 6. 2 times 2 is 4. Then 2 times 3 is 6. Well, no, 4 times 1 is 4. 4 times 3 is 12. Carry the 1. So that's a 9. Then the 2 just drops down. 6 plus 4 is 10. Carry the 1, so that's going to be a 7. And 9. My god, I've been doing so much talking. 6 times 9 is 54. Carry the 5. 9 times 3 is 27. Plus 5 is 32. Carry the 3. That's 57. 6 times 6 is 36. Carry the 3. 6 times 3 is 18, so that's 1. 2. 6 times 6 is 36, so that's going to be 38. Okay, then the 4 drops down. 6 plus 2 is 8. 7 plus 1 is also 8. 13, carry the 1 to 4. Hey, 3 in a row. I'm pretty good at this multiplication stuff. Getting full points, too. Pretty proud of that. 7 times 2 is 14. 7 times 5 is 35, plus the 1, so 36. 7 times 6 is 42, plus the 3 is 45. I think it's plus 3. I'm getting pretty tired. Okay, what are we doing? 2 times 2 is 4, yes. 2 times 5 is 10. There we go. Then the 4 drops down. 6 plus 4 is 10. Carry the 1, so that's a 6. 7. 1. No, what did I get wrong? Did I really add 4 and 3 incorrectly? That's embarrassing. Okay. 5 times 6, 30. 5 times 1 is 5. Plus 3 is 8. 5 times 4 is 20. 6 times 6 is 36. 6 times 1 is 6, plus 3 is 9. 6 times 4 is 24. Okay, 0 drops down. 8 plus 6 is 14. Carry the 1. It's a 10. Carry the 1, so that's 7. That's 3. Oh, come on. Oh, that's 2. This is embarrassing. Like I said, it's late. It's 11:38 here. I'm awake because it is New Year's Eve. I may as well stay up until midnight for some reason. Actually, I just wanted an excuse to play Donkey Kong Jr. Math. 2. No, that's wrong. Okay, I wanted to go back and edit the 3, right? But that locked in that 3. So now those 2 digits are completely wrong. So now the sum beneath them is going to be wrong too. So I've totally screwed this all up. Okay, 2 times 7 is 14. 2 times 3 is 6, plus 1 is 7. 4 times 2 is 8. Well, we can at least get the first part of this correct. Yeah, I don't even know what's going on anymore. How do I only have 2 digits wrong? Okay. 8 times 7 is 56. Carry the 5. 8 times 3 is 24. Plus 5 is 29. Carry the 2. Okay, so that should be a 4. Wait, what? Oh, Oh, come on. Well, 4 plus 7 is 1, so I can get that one correct at least. Oh, that doesn't count. Oh, probably because something carries. Okay. 4 is locked in, and this is going to be a 2. That was embarrassing, y'all. I am so sorry. Again, it's okay, because nobody is watching this. Wait, no. Oh, I messed it up again. So that's going to be wrong. That should be an 8 there. So I'll have to remember that when I'm carrying it down. That's actually an 8. That's 6, an 8, and then I have to fix that 0 into an 8 because I suck. Oh, that 2 into an 8, I'm sorry. Oh my god, there's still 3 more rounds left of this shit. Okay, 7 times 4, 28. Okay, I got that one right at least. Finally. No! You can tell I'm tired. I'm making all kinds of garbage mistakes. Okay, so that's supposed to be an 8. 8 plus 6 is 14, carry the 1. So now I just have to go fix that stupid 8. Oh my god. So embarrassing. One more level. No, that's supposed to be... I know what I do wrong as soon as I let go. Like, the problem is the execution is so sloppy because this game is bad. Okay, glad you're happy, Donkey Kong. One more level and then we're done. Calculate A and Calculate B are multiplayer, so I'm not going to play them. I only do single-player stuff here because I don't have anyone to play with. And if I did, I would not make them suffer through this. 2 goes into 12 6 times. Evenly. Easy. 5 times 7 is 35. With the remainder of 2. Oh my god. Six times 1 is 6. And we are left over with 12. 6 times 2 is 12. And we are left with 0. Are you seriously doing 36 divided by 1? Why do we have to work this out? It is clearly... Oh, this is so stupid. This is such a waste of my time. It's clear... Oh, God. Why did they do that? Why did they do... Oh. Do you really need help to divide by 1? 7 times 9 is 63. With the remainder of 1. I cannot wait for this stupid game to be over. Oh my god, it takes so long to get over to the actual problem. 4 times 6 is 24. With 3 left over. Oh my god. 5 times 4 is 20. With 3 left over. Three times 1 is 3. The 8 drops down. 3 times 2 is 6. And we have a remainder of 2. 9 times 7 is 63. With 4 left over. One more! One more and then we are free. Oh, and of course, it's all the way at the top. 4 times 9 is 36. With a remainder of 1. That is Donkey Kong Jr. Math. Let us never speak of this again.